All right, guys, any questions on the homework before we get started? Huh? You got aspirin? Oh, glass. Yeah. There we go. The muffin? It was good. It was very good. All right, guys, I believe we stopped here. Yes. All right, guys, so we're picking up here, picking up where we left off yesterday, multiplying these rational expressions. Now, the first thing we can do is multiply numerator with numerator, denominator with denominator. Top of the fraction with the top of the fraction, bottom of the fraction with the bottom. So we'll multiply our numbers first. 3 times 6 is 18. X to the 5th. Question? 3 times 6. X to the 5th times x would be x to the 6th. Y squared times y squared would be y to the 4th. 9 times 8 on bottom would indeed be 72. X times x cubed, x to the 4th. And y times y is y squared. So the first thing we want to do is multiply our like terms together. Then we can simplify. First thing we can simplify is the 18 over 72. So we can go through and find the factors between 18 and 72. Or we can pull up the calculator and say 18 over 72, which is 1/4. So the greatest common factor between 18 and 72 is actually 18. So the number on top reduces to 1. The number on bottom reduces to 4. We'll leave writing the 1 for a minute, because if everything does reduce out of the numerator, then we'll list it as 1. If there's any variables or any terms left on top, we can just leave those terms there, because we don't necessarily have to write 1 times x. It's just going to be x. Now our variables, x to the 6th over x to the 4th. When we divide like bases, we subtract. So 6 minus 4 is 2. Is it bigger on top or bottom? Top, so it stays on top. So it's x squared. Y to the 4th over y squared. 4 minus 2 is bigger on top or bottom? Top. That's it. Whichever one's bigger determines where it stays, because with x's, how many x's do we have on top? 6. How many do we have on bottom? 4. So 4 of them on top and bottom would reduce. They're going to go away, which means all the ones on bottom are gone. We only have 2 left on top. Yes. Yeah, because a more drawn out way is 1, 2, 3, 4, 5, 6. 2, 3, 4. Because as we reduce, this one would reduce. 2, 3, 4. We only have 2 left on top. Because x to the 6th is just saying we multiply x by itself 6 times. Same with x to the 4th. Then we're just reducing 1 at a time. Or we can just subtract. Does that make sense? Any other questions on this here? All right. Let's look at this one here. Now this one here, we don't have monomials. We don't have single terms in the top and bottom. So the first thing we're going to have to do is factor all of them. Once we finish factoring, we'll multiply, then simplify. Now out of these 4, The 3x isn't going to reduce because it's just 3x. Now the first one of these I would simplify or factor is going to be our 3x minus 3x squared, because is there a greatest common factor between 3x and 3x squared? 3 and x, because both 3 and 3 have a common factor of 3. X and x squared have a common factor of x. So we can remove the 3 and x from both terms. Now if we factor 3x out of 3x, we get 1. Minus, we factor the 3x out of 3x squared, we get x, leaving us with 1 minus x. There's a good chance we're probably going to need to pull a negative out to make that x positive, but we can leave it as this here for now. What do we want to factor next? The x squared plus x minus 20 or the x squared plus 4x minus 5? The top one. Now x squared plus x minus 20, there is no greatest common factor between these three terms. So we'll do our two sets of parentheses. Since the third term is negative, our signs are opposite. One's going to be positive, one's negative. Factors of x squared are x and x. Our factors of 20 are 1 and 20, 2 and 10, 4 and 5. Which one of these factors do we want to try first? 5 with the plus, 4 with the minus. And we can check this here just to make sure. X times negative 4, negative 4x. 5 times x is plus 5x. X, positive x, which is the middle term we wanted. All right. That leaves us with our x squared plus 4x minus 5. Here, the no greatest common factor. Third term is negative, so the signs are plus and minus. Factors of x squared. X and x. Factors of 5 are 1 and 5. We'd want the 5 with the plus, because having it x plus 5 does give us common factors on top and bottom, so something will reduce. Now we can check it just to make sure. X times negative 1 is negative x. 5 times x is positive 5x plus 5x, giving us the positive 4x term we wanted. So we do have everything factored, yes? So now we need to multiply, yes? We'll have the 3x times our 1 minus x. Now we need to multiply it by the x plus 5, yes? Okay, so we'll multiply it. And x minus 4. Because when we have two sets of parentheses written next to each other, that is multiplication. We're multiplying. We're not going to distribute it out, but it is multiplied. If we do the same thing on bottom, we'll move the 3x up front, because 3x is being multiplied by our x plus 5 times our x minus 1. What's in common on top and bottom? The 3x and 3x, and that simplifies out completely. And the x plus 5 and x plus 5. Because 3x over 3x is 1, so it's gone. Yes, now the x minus 1 is going to simplify, but we're going to have to do something to it. Because the 1 on top is 1 minus x instead of x minus 1. They're not the exact same, but they are pretty close. However, on one, the x is negative, the other, the x is positive. On the one on top, the 1 is positive. On bottom, the 1 is negative. Every term in those two expressions, the signs are opposite, yes? And if it works out that way, Let's take the 1 on top. I'm going to factor a negative out. So if we factor a negative out of negative x, it becomes positive x. If I factor a negative out of the positive 1, it becomes negative. So if you have two sets of parentheses that are almost the same, except that every term sign is flipped, we can pull a negative out of one of them to get them to match up. And yes, now our x minus 1 and x minus 1 will simplify, leaving us with negative x minus 4. So it almost would have been probably nicer to factor not a 3x at the beginning, but negative 3x. So we fix that sign, and we don't have to worry about it later. Does that make sense? Really, what was the key to this whole thing? Factoring. Once we factored, it was crossing out what's in common and go from there. Get ready for the next one. Five x is a single term. It's not going to factor, so we can go on and put it down. 5x minus 5x squared. What's the greatest common factor between 5x and 5x squared? 5x. But it looks like we're going to have a negative x again, yes? Why don't we, instead of waiting to get rid of that later, why don't we tack that negative out with it? Because it's nicer to have that variable, or especially the variable with the biggest exponent, positive. Because then when we go factoring or do anything later, it makes it easier to work with. Now the 5x squared, the negative 5x squared, is going to become positive x. The 5 factors out completely. The x squared is reduced to x. And since we took the negative, it's taking it from negative to positive. Now the 5x up front is going to factor out completely, so we would have 1. But because we took the negative out, it's going from positive 1 to negative 1. Now we will write it in standard form here in a minute. I left it as negative 1 plus x so that we're not factoring something out with the negative and flipping things all at the same time. Just a lot at once. We'll do it one piece at a time. Now the question is, which of the other two do we want to factor first? The top one, x squared minus 5x plus 6. Now again, we'd always look for greatest common factors first, something that we can pull out of all three terms. Here, there's not one. So we go to our two sets of parentheses. Since the third term is positive, the signs are the same and match the sign of the middle term. So negative and negative. Factors of x squared, x and x. Factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3. We could check this here, but these are the correct factors. Because x times negative 3 would be negative 3x. Negative 2 times x would be negative 2x. Negative 2 minus 3 is indeed negative 5. X squared minus 4x plus 3. Third term is positive, so the signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared are x and x. Factors of 3 are 1 and 3. Really, there's no other way to write these. It's either x minus 3 times x minus 1 or x minus 1 times x minus 3. And if we check it, x times negative 3 would be negative 3x. Negative 1 times x is negative x. Negative x minus 3x is indeed negative 4x. Let's multiply these together. On top, we'll have the negative 5x times x minus 1 times our x minus 2 times our x minus 3. On bottom, we'll have 5x times x minus 1 times x minus 3. Now we just need to simplify what's in common on top and bottom. X minus 1, x minus 1, x minus 3, x minus 3, yes. Anything else in common? The 5x over 5x would also reduce. We still have the negative and x minus 2 on top. Is there anything left on bottom? No, so it reduced to 1. Now because the denominator is 1, we don't have to write it. But if the numerator is 1, the top of the fraction is 1, we have to write it as 1. Questions on this here? Are you ready for this next one? Well, the nice thing is 2x squared doesn't factor. That's as simplified as it gets. There's actually one more that doesn't factor. X plus 3. X plus 3 is as simplified as it gets. There's no greatest common factor. The degree is 1. Simplified. So really the only thing we need to factor is the 2x squared minus 10x and the x squared minus 25. If we look at the 2x squared minus 10x, is there a greatest common factor between these two terms? 2x. Now when we factor 2x out of 2x squared, we get x minus 5. Yes, the bottom would be. So x minus 5, yes, and x plus 5. Because it is a difference of perfect squares. So x and x give us our x squared, 5 and 5 to give us our 5, 25. Plus and minus, minus and plus. But yes, we did write it for a while. X in parentheses squared, 5 in parentheses squared. And we did that to get the a and b terms, what we plug in for x and x, 5 and 5. So x squared minus 25 is x plus 5, x minus 5. Now we're going to multiply these together. So on top we have 2x times x minus 5 times x plus 3. On bottom we have 2x squared times x minus 5 times x plus 5. Let's see what's going to cancel. X minus 5 and x minus 5. And the 2 and 2 will cancel out completely. However, x over x squared, is that going to simplify out completely? Well, no. The one on top, yes. Because x over x squared, one of the x's on top and one of the x's on bottom will cancel. But we still have 1x on bottom. Because our 2 minus 1 is 1, bigger on bottom, so it's going to stay on bottom. We still have an x on bottom. And we also have the x plus 5. So here we're left with x plus 3 over x times x plus 5. Questions on this here? Because once we get the hang of factoring these, simplifying them is not bad. It's really just getting them factored, then simplifying. Questions on this here? Are you ready for the next one? C to the third plus 8 over c to the fifth minus 4c to the third times c to the sixth minus 4c to the fifth plus 4c to the fourth over c squared minus 2c plus 4. Let's start with this here, c to the fifth minus 4c to the third. Is there a greatest common factor between these two terms? C to the third. Because they both have c there, and the most we can take out of each one is 3. So we're reducing the power of each c by 3. So our c to the fifth is going to become c squared minus 4. Because c to the third became c to the 0, which is just 1. So it's simplified. Let's look at this other one here. C to the 6th minus 4c to the 5th plus 4c to the 4th. Greatest common factor of c to the 4th. And again, it's going to reduce each of these here by a factor of 4. See? Leaving us with c squared minus 4c plus 4. So that's greatest common factor. C cubed plus 8 doesn't have a greatest common factor between them. C squared minus 2c plus 4 does not. Let's look at c cubed plus 8 first. This here is our sum of two cubes. Minus ab plus b squared. Now, if we can find our ab terms, we just have to plug them in. A cubed is being replaced by c cubed. So if I want to find out what's going in for a, we just have to take the cubed root of c to the third, which is just c. To find our b term, we're going to take the cubed root of 8, which is
I need Caitlin,
2.
Cooper, Bott, Laren Thurman, and call your butt. Come to the office.
Questions on how we found A and B or how we're about to plug this in? Because the first part's A plus B, which for us would be C plus 2. Our next one's going to be A squared, which for us would be our C term being squared, minus A times B. So A would be C, B would be 2, plus B squared, which in our case is C squared. Questions on how we got to this point here? Now that second set of parentheses with that cubic is kind of looking familiar, yes? Not that we've seen it before, but c squared is what? C squared minus c times 2 is 2c, and c squared is 4. Oh, wait a minute. What do we have on bottom? C squared minus 2c plus 4, yes? I can leave it alone. I don't even have to try factoring it. Because since we do have 1 on top that is the exact same, that means when we multiply, those two are going to cancel out. They're going to simplify out. So whatever the factors of c squared minus 2c plus 4 are going to match up with our other c squared minus 2c plus 4, so there's no reason to factor it. Also, c squared minus 2c plus 4 doesn't factor. So there is that. And the reason we know that is that the quadratic part of a sum or difference of two cubes is never factorable. It doesn't factor. The other two, I'm going to start with our c squared minus 4. It will factor. It's our difference of perfect squares. So it'll factor to what? C plus 2, c minus 2. Difference of perfect squares, c squared, c and c. 4 is 2 and 2. Since they're being subtracted, we'll have our plus and minus. Now we'll move on to our other one, our c squared minus 4c plus 4. Since the third term is positive, the signs are the same and match the sign of the middle term. Negative and negative. Factors of c squared are c and c. Factors of 4 are 1 and 4 or 2 and 2. Which one do we want to use? 2 and 2. And now at this point here, we're going to multiply everything together. We'd have c to the fourth plus times c plus 2 times c squared minus 2c plus 4 times c minus 2 times c minus 2. On bottom, we'd have c cubed, c plus 2 times c minus 2 times c squared minus 2c plus 4. These questions on what we've done so far. So we factored. That's actually about all we've done so far. Because c squared minus 4 is c plus 2, c minus 2. C cubed plus 8 is our difference of two cubes. Yes. 40 or 23. What's in common on top and bottom? C plus 2, c minus 2, and our c squared minus 2c plus 4. Now, c to the fourth over c to the third is going to be c. 4 minus 3 is 1, and since it's bigger on top, it'll stay on top. And the only thing left on top is c minus 2. Yes, since there's only one of them on bottom, it will only simplify with one on top. If there was another c minus 2 on bottom, then yes, they would both simplify. So the big thing with this here is just factoring. Because once we factor it, multiply and reduce. Questions on this here? All right. Cool. Okay. All right. We're going to look at this one next. Yes, we are skipping one, but I want to look at this one. Find the product of x plus 2 over x cubed minus 27 times our x squared plus 3x plus 9. Now, even though the second one doesn't have a denominator, it's just 1. It does have one, it's just 1. If we look at the first rational expression, x plus 2 is as simplified as it gets. It's just x plus 2. Now we will need to factor our difference of two cubes here, our x cubed minus 27. And the difference of two cubes follows the form of a cubed minus b cubed. Factors a minus b times a squared plus ab plus b squared. Now we will need to find the a and b terms that will be plugged in to the spots over here. And to find that, we match it up with our terms that are given. A cubed matches up with x cubed. So to find the a value, we just take the cubed root of it, x. So in all the a's over here, we're going to plug in x. Then for our b, it's going to line up with our 27. B cubed is 27. So we take the cubed root of 27. It's 3. So the values we're plugging in for b are going to be 3. So when we factor this, our first set of parentheses is a minus b, which for us would be x minus 3. In the bigger set of parentheses, our first term is a squared. So it would be that first term squared or x squared. In the middle, we have ab, so we'd have our x and 3 being multiplied together. And in the last spot, we'd have 3 squared. Now, before we mess with the x squared plus 3x plus 9, trying to see if that factors, let's see what this simplifies to. Because we'd have the x minus 3. X squared as well, x squared, plus 3 times x is 3x. 3 squared is, wait a minute, that is the same thing as what we have here, yes? So there is no reason for us to try to factor it. It won't factor. So we'll just leave it alone. Because even if it does, those two are the exact same. They're going to simplify out. So we're going to multiply them together, yes? Really, we're just making that one fraction, yes? I mean, we could rewrite it out as x plus 2 times x squared plus 3x plus 9 over x minus 3 times x squared plus 3x plus 9. But we really are just merging those two together. That's the nice thing with multiplying with these parentheses and what's in common. The x squared plus 3x plus 9, leaving us with that's it. So really the whole thing with this multiplication of these polynomials is just factoring. We factor it, multiply, simplify what's in common. That's it. Questions on this here? Are you ready for the next one? X minus 7 is nice. It's just x minus 7. It doesn't factor. Well, with these cubics, there's a good chance that what? The x squared minus 2x plus 4, we might not need to factor it. Because of our x cubed plus 8. That's sum of two cubes. Our a term is going to be our cubed root of x to the third, which is x. Our b term is the cubed root of 8, which is 2. Well, we're going to have to plug 2 into b squared. What was it? Well, what is 2 squared? 4. Okay, that kind of matches up with our other one, yes? AB would be 2 times x. Okay, it's looking like that's going to match up again. Now let's plug it in. A plus b. A is x plus b is 2. Here we'll have our x term, our a term being squared, so x squared minus a times b plus b squared. Which, when we simplify it, it's 2x plus 4. On top, we will have x minus 7. And really, we also have the x squared minus 2x plus 4. Put on and multiply them, stuck them all together. That's the nice thing with these parentheses. Multiplying is just putting them next to each other. What's in common? The quadratic. Questions on this here? We feel good with this here. Yes. That's it.